Hello and welcome to PH Physics. Today's explainer is electrical power, the rate of energy transfer in a circuit. P equals I times V. By the end of this video, you'll know both useful forms of the equation and where the heating effect comes from. Electrical power is the rate at which energy is transferred in a circuit. The formula, P equals I times V, current times voltage. There's also P equals I squared times R, current squared times resistance, useful for calculating heating in a resistor. Three things. 1. Measured in watts, where 1 watt is 1 joule per second. 2. Bigger appliances draw more power. A 2 kilowatt kettle moves 2000 joules every second. 3. Heating in a wire rises with the square of current. Why thin wires get dangerously hot under heavy load. Common slip, forgetting that heating effect scales with current squared. Double the current, 4 times the heating. That's why house wiring is rated for specific current limits and why fuses protect against overcurrents. Quick example, a 230 volt kettle draws 9 amps. Power is 9 times 230 equals 2070 watts, i.e. just over 2 kilowatts. A 6 ohm resistor with 3 amps through it, P equals I squared R equals 9 times 6 equals 54 watts of heat dissipated. Right, if any of this is going to stick beyond this video, drop into phmaths.com. You'll find a free 4-week GCSE higher revision planner ready to download, plus mastery workbooks across maths, physics, biology and chemistry. One for every higher topic subject, every answer fully worked, every common slip flagged. Simple explanations, serious results. See you next video.